Okay, we're gonna review this 11.1. Make sure you sort of really kind of get it, and then I'll show you folks a magic trick. And then after break, we'll do the test of independence 11.2, and also ANOVA. You have your first homework on chapter 10 due on Sunday, and they all kind of start happening Tuesday, Thursday, Sunday, Tuesday. Our file is going to be on December 16th, and I would really like to have it at 5 o'clock. Because if we start at 5 o'clock, then that allows me to give you 15 minutes of bonus time before we run into the next exam. So is everybody all right with that? So if I switch that to 5 o'clock?
Yeah.
The final?
Yeah.
Okay.
Is that just when class starts?
Yeah, when class starts.
Oh,
So we'll make that 5 o'clock. Perfect. And don't forget, exam 4 is rolled into the final, so a lot heavier on chapters 10 and 11. I want to share this with you folks. We had it, someone brought this up in one of our meetings, which is kind of cool. It's just because we were talking about how there's a lot of stress going on in students' lives, in our lives, a lot of changes, a lot of transition, and kind of some things we can do about working with that. But they brought up this great quote, which I love, which is that we are socialized to see what is wrong, missing off, to tear down the ideas of others and uplift our own. So very often, we're kind of geared to find what's wrong, right, and point out what's wrong, instead of try to fix things, as opposed to kind of and kind of say, well, I would do it this way, so my way must be the right way, and yours must be the wrong way. And it's interesting because when I was younger, I used to be really good at listening, and then somewhere along the line, I think when I had a business and I hired a bunch of high schoolers. And you had to be like, no, stop, do this, and you had to be, it was all about fixing things. I became more of a fixer and less of a listener. But it's important to listen sometimes. Sometimes people just need someone to listen to them, not fix their problems or try to give them solutions. To a certain degree, our future may depend on learning to listen, and listen without assumptions or defense. So it's kind of a really cool quote I liked a lot. And it's interesting because they also pointed out things like when people are trying to deal with stuff, their issues, don't be like, why are you doing it that way? I would do it this way. You should do it that way. Your solution may work best for you, but it may not necessarily work best for them. And so just kind of bear that in mind. Okay, and keep in mind that sometimes people just want someone to listen and not always fix their problem. Okay. All right. You should take a picture of this study guide for the final. Our final study guide is going to be parts of all the previous study guides. These are the parts. Just those problems from exam 1, just those ones from exam 2, just those from exam 3, and then all of exam 4 study guide. Okay. Good. Moving on in 5, 4, 3, 2, 1. All right. So 11.1, goodness of fit. That's the chi-squared statistic. We're checking to see whether a distribution fits what we expect it to fit. Our H0 is that O sub I equals E sub I. Our H1 is that O sub I does not equal E sub I. In other words, what actually occurs is what expected, is what is expected, that's H1, and H0. H0 is what occurs equals what we expect. H1 is what occurs does not equal what we expect. We did this with soda flavors yesterday. Remember, the observed values are always what is given to you from the sample or from the survey. So you never calculate those. The observed are always given to you, always. The expected, you will always calculate. If they're equally distributed, such as the problem you just did, you take your total, you split them equally amongst every category. There's 6 categories, 200 rows, divided equally amongst all 6. 200 divided by 6 for all of them. If it's a percentage in each group, like 30% cherry, 10% grape, you take your total, 30% of the total, 30% of 200 would go for cherry, 10% of 200 would go for grape. Right, take your percentage, multiply by the total. Expected frequencies, which ones can be decimals? Observed or expected? Expected. Your observed will never be decimals. You can only observe whole numbers. You can calculate, you can expect 2.4 children. You will never observe 2.4 children. All right, and then we have our test stat, which is the chi-squared. You don't need to call it chi-squared. You can skip that all together and just call it test stat if you want. How do we find it? We take, for every category, we take the observed value, subtract the expected value, square that amount, and divide by the expected value. You do that once. You do that for every single category, and then you add them all up. That's your chi-squared. Now what you'll notice is that degrees of freedom is number of categories minus 1. Why is that? Because how many times am I taking my observed minus expected and dividing by squaring and divided by the expected? How many things am I adding there? I'm doing that calculation once for every category. So the more categories I have, the more numbers I'm adding. Does everyone understand what I'm saying? The O minus E squared over E, I do that once for grape, I do it once for strawberry, I do it once for orange. So the more categories I have, the more times I do that, the more things I'm adding up. So that's why the degrees of freedom depends upon the categories, because again, more categories, more things you're adding, the larger your number should be. So the degrees of freedom is number of categories minus 1. If you get something like the one today, where you have decimals, or on your homework, if you get ones that are like you have 5 or 6 or 7 or 8 different items you need to multiply and add and stuff like that, you can use a calculator. That's a good time to use your calculator and lists to do this. I'll show you that in a minute. On the exam, your observes are going to be whole numbers. Your expecteds are going to be whole numbers. You're going to get nice numbers, and you're only going to get like 3 of them. So it's just as easy to just, do it all by hand, just like we did today, because you have to write them out anyways. But on your homework, you might want to use this list 1 thing, list 1, list 2 thing. So how you do that is in your calculator, you put your observed values into list 2, you put your expected values into list 3, and then into list 1, you go up into that spot and you do, in parentheses, L2 minus L3 squared divided by L3. Hit enter, they'll calculate all those for you, but then you're not done yet. You still have to add them all up. You have to sum them to get to your test stat. So your test stat would be the sum, that number there. And I will try to show you that in just a minute. So here's your hypothesis test summary. Again, step 1 is H naught is O sub I equals E sub I. H1 is O sub I is not equal to E sub I. Step 2, find your critical value from the chi-squared table. Calculate your test stat. And then decide to reject or not reject the null hypothesis and summarize for the claim. So we'll take a look at this problem here. What did you get for your expected values? Yeah, it should be 1/6 of 200, right? 1/6 of 200, which is 33.3. Give me at least one decimal place, at least one. If you did 2, that's great. If you did 1, that's acceptable. You should have at least 1 though. Okay, so then my step 1 is going to be O sub I equals E sub I. For my H naught, H1 will be O sub I is not equal to E sub I. My critical value, look that up on the table, degrees of freedom is 5, alpha's 0.025, and what is my critical value? 83333. Great, so 12.833. Right, I lied, I know I said I never used that one, but I probably did. So then I'm going to find my test stat. So 30 minus 33.3 squared over 33.3. 27 minus 33.3 squared divided by 33.3. 48 minus 33.3 squared over 33.3. 37 minus 33.3 squared over 33.3. 27 minus 33.3 squared. Do you have to write this out? Yes. Thank you. And you got? Great, 9.77, somewhere in here. So it's in the clear area. Am I going to reject H naught?
No.
No. So do not reject H naught, which means I do not have enough evidence. 2. Okay, so here's the deal. If you said, well, Ms. Young says it's always going to be H, that my claim is, we'll do it in 2 different ways. We'll do the H naught in blue. You chose that as your claim because I said that H naught's always your claim for chapter 11. And if you said, well, but I read the numbers, the words, and the word says that behaves differently, it's different, then we'll do that. If you chose H1 as your claim, that's fine too. I don't care. We'll write that one just as long as you're consistent with that in step 5. So, if you did the blue one, you'd say reject, claim that proportions are as expected. Done. Or, so this is one possibility. Second possibility would be if you chose H1 as your claim, because you said that they behave differently, then you could have said support claim.
We don't have enough evidence.
Yeah, either way, it's not enough evidence. Claim that loaded dice behaves differently. So I don't care which of those you use. Just, as long as you're consistent. If you support, you better say differently. Say reject, you better say the same. Right, or as expected. Questions on those? No? Okay. Let me show you, before I forget, how to put these into the calculator, which you will want for your homework. All right, so I have 30, 22, 48, 37, 27, and 31 as my observes, and I have 33.3 for my expected. All right, so I'm turning this on. I'm going to go to stat edit, and I'm going to clear out my lists. I step in there, clear enter, clear enter, clear enter. And in the list 2, I'm going to put in my observes. 30, 22, is that right? 48, 37, 27, 31. Okay, great. Now for list 3, I'm going to use 33.3 for all of them.
You said 22, it's 27 and 30.
Is it 27? Yeah. Which one's 27?
Oh, no, under 30.
Under 30? Okay. That was 27?
Yeah.
Okay, great. Thanks, guys. Thanks, folks. Okay, good. So now I have those in there. Now, for list 1, I want parentheses. And for parentheses, as you're getting in trouble, I want my observed, my L2, so second L2, minus my expected L3s, so second L3, and parentheses. So that amount, I need to square it. So I'm going to raise it. Here's my little above the division sign, is my my exponent sign, so raise it to the second power. And then divide by my expected L3, second L3. Bam. And there they all are. I'm not done yet. I need to add them up. So I'm going to go to stat, count, one of our stats of L1. And the sum of my x's, 9.77. There you have it. Good. So again, stat edit, put your observed in list 1, your expected in list 2, and then in the list, sorry, observed in list 2, expected in list 3, and then in L1, go up so your cursor's actually on, not here, but actually on the L1 itself, and do parentheses, no parentheses, it's going to be all messed up. Second L2 minus second L3, and parentheses, we want that amount squared, to raise the second power, and then divided by your expected L3, second L3. And again, you're not done yet, you still have to add them up. So stat, calc, one of our stats of L1, second L1, and that will give you your sum of the x's, 9.77. I would recommend that for any of your homeworks that involve a lot of decimals or involve more than 6. Okay. Good. We did the other one already. All right, great. So 11.2, contingency tables. Oh, let's take a little break. All right, so we're a little bit early. That's fine. We're going to take a break now. It is 5:46. We'll come back at 5:56, and now I'll show you a magic trick. My second best magic trick.